Hello students, today I want to share a topic with you, chapter 2nd of chemistry, that is acid, bases and salt. As you all know, on the basis of chemical properties, all compounds classified in three groups, that are acid, base and salt. As you all know, acids are having a H plus ions and acids are sour in taste. Bases are having a OH minus ions and they are soapy in touch and bitter in taste, while salt is the mixture of acids and base and it is neutral. Now, we need some indicators for testing acids and base. How do we indicate that this is an acid or this is an base? So first of all, we get to know what do you mean by indicator. So indicator is what? Dye that change color when it is put into an acid or base. So what is the dye? Common indicators we need to test for acid and base. So two types of common indicators are there. First is natural indicators and second are synthetic indicators. So in natural indicators, first is litmus. Now what is litmus? Litmus is natural indicator and litmus is made up of lichen. You all know what is lichen? Lichen is a symbiotic relationship between algae and fungi. Litmus is of two types, blue litmus paper and red litmus paper. A blue litmus paper always, when dipped into an acid, it turns blue litmus to red, but when red litmus paper dip into a base, it turns red into blue color. Got it? Now next is synthetic indicators. There are also two types, methyl orange and phenol naphthalene. Methyl orange and phenol naphthalene, they both are synthetic indicators. They need to be used in the chemical laboratories for titrations and all. Now, the next topic is olfactory indicators. The word olfactory means relating to the sense of smell. The example for the definition is substance whose smell or odor change in acidic or basic solution are called olfactory indicators because they are relating to the sense of smell. Now, we take the example of onion. Onion, you all know onion has its own characteristic smell. You all can smell the onion. But when some cloth strip treated with onion, you keep it overnight, some cloth strip treated with onion overnight and you add few drops or 2 or 5 drops of NaOH solution in this cloth strip, and you can see you could not detect the smell. But in the same, when you treat this cloth strip with onion with HCl solution, that is acid, you can see you do not destroy the smell of onion because onion has its own characteristic smell. Now, like in vanilla also, they both are same. They are having their own characteristic smell. So, I have taken one sample problem. We have taken the 3 test tubes to test or indicate the color of the litmus paper. In the one test tube, I have taken distilled water. First test tube, I have taken distilled water. In the second test tube, I have taken acid solution. And in the third test tube, I have taken basic solution. Now, I will take only one common red litmus paper to see the change of color in this test tube. When we dip the red litmus paper in the distilled water, there is no color change. No color change. But in the next test tube, when we dip the red litmus into the acid solution, there is no color change. But when you dip the red litmus paper into the basic solution, it will turn in blue color. So there will be a change of color. When you dip the red litmus paper into the basic solution, it will change into a blue color. So like this, we can identify or indicate the color change. In the first, I have taken distilled water, no color change. Second, I have taken the acid solution and dipped the red litmus paper, no color change. But if I dip blue litmus paper into the acid solution, there will be a change of color, because when we dip the blue litmus paper into the acid solution, it will change into the red color. And the third, you can see we have dipped the red litmus into the basic solution, it will turn in blue color. Okay, thanks.